Hello and welcome back to Geometry. This is part 2 of section 1-4, Angle Measures. Let's complete the example problems together. Example 1 is a real-world problem on angles and their parts. We will use the map of a high school shown. Here we've got a faculty parking, the auditorium, and the library and office, and a bunch of pathways connecting them with various points labeled in the diagram there. So first, part A, name all angles that have B as a vertex. Angle B is right here. So I'm going to draw in or highlight in all possible angles connecting to vertex B. So we could do one like that. That would be angle A, B, D. We could also do here angle A, B, C, really would be a straight angle. We could do, let's see, we could do D, B, C. Not sure if the green showed up there very well. There we go. Angle D, B, C. And any others? Yes, we could go with the other side of the road and look at, no, that's not vertex. B from, I think that's it. We can also use the numbers. Notice angle 1 and angle 2 are different names for ABD and DBC respectively. How about the sides of angle 3? Angle 3 is found right here. We'll trace that out, vertex at C. So the sides would be C to B, so a ray starting at C going through B, and ray CE. How about another name for angle GHL? Let's find and trace angle GHL. G to H to L right there. Looks like angle number 7. So we can call it angle 7. Any other angles from H? H only has those 2 rays, so no, so you could just call it angle H. That would be acceptable here. And finally, name a point in the interior of angle DBK. So let's find angle DBK. It looks like the same angle as DBC. A point on the interior would be anything on this side. So you cannot include anything along the same line, which means that just leaves angle E, point E. Okay, example 2, measure and classify angles. Copy the diagram below. Done. Extend each ray. Classify each angle as right, acute, or obtuse. Then use a protractor to measure the angle to the nearest degree. This is why you will need to extend the ray. It is most likely your protractor would be larger than the diagram itself. So you want to make sure those rays are nice and long so they intersect with the scales on your protractor. We'll start with classifying. I have angle MJP, MJP. That's the one marked with the square there, so that is clearly a right angle. Next, we have angle LJP, L to JP. That's larger than the right angle. That would make it obtuse. And finally, NJP. Angle NJP is a very teeny tiny acute angle. All right, now I do have a measuring tool here on Notability. I know it looks like a ruler, but I can use my 2 fingers here and I can rotate this ruler around and it will tell me the degrees of rotation there in the center. So I will start down here and we will confirm this starts at 0, and as I rotate this way, numbers are increasing from 0. If I go this way, numbers suddenly start at 180 and are counting down. So I want to start at J to P as my 0 point and rotate in this direction up until the edge of my ruler is along JM, and that is confirmed 90 degrees. "90 degrees is the definition for a right angle, so that will work. How about for angle LJP? So once again, here is 0. I'm going to go rotate in this direction towards increasing the number from 0 until I line up with the other ray, JL. That's at 105. So this is an obtuse angle of 105 degrees. 105 is more than 90. Just to double check there. And finally, NJP. Reset back to 0. 0 on JP. Rotate up from 0. Align to JN, and I get 20 degrees. So that is an acute angle of 20 degrees. 20 degrees is indeed less than 90. That meets the definition for acute. Finally, example 3, measuring and classifying angles. In the figure, ray KJ and ray KM are opposite rays, so confirming that this is indeed a straight line. And ray KN bisects angle JKL. So that highlighted ray bisects this highlighted angle, which means I'm going to go ahead on my diagram and draw automatically matching arcs in those angles. By definition of the bisector, those are automatically congruent. Let's keep going. If the measure of angle JKN, which is this one, equals 8x minus 13. Switch back to blue here. 8x minus 13. And the measure of angle NKL, I did this one in orange. Let's do this one in pink. NKL equals 6x plus 11. 6x plus 11. Find the measure of angle JKN. Oh, that's the same one as before. We'll use orange again. Okay, well, as I already pointed out, based on that bisector, these two given expressions represent two measures of congruent angles. So by the definition of angle bisector, angle JKN is congruent to angle NKL. Therefore, the two given measures are equal. So I can set up my equation, 8x minus 13 is equal to 6x plus 11, and now we can solve for x. I will subtract 2x from both sides. We get, not 2x. I'm already thinking ahead. Excuse me. Subtract the 6x from both sides. We are left with 2x on this side. Subtract, add 13 to both sides. Get rid of it over here. 11 plus 13 is 24. Divide both sides now by 2 to arrive at x equal to 12. Am I finished yet? No, I need to find j, k, n. So let's plug this value for x into the expression for j, k, n, which was 8 times the value of x minus 13. 8 times 12, 8 times 10 is 80. 2 times 8 is 16. 80 plus 16 is 96. Minus 13, 96, minus 10, 86, minus 3 leaves 83. And this is the measure of an angle, so I would expect it to be in degrees. There you have it. This concludes the examples for section 1-4. Thank you very much for following along. So long, farewell. Enjoy the rest of your day.